Well, good afternoon. Today's topic is a little different. For one thing, we're re-recording the lecture because we didn't capture it in the live classroom. But it's the same lecture, same material, same content. The nice thing is the lecture is fairly short, so it won't be so long. What we did do on Tuesday was first a conflict scenario exercise. We did this in class. The documents are available in RAMCT. It's a two-page document. On the first page, you have a scenario. Basically, you have 4 team members to your team. 1, 2, 3, 4 people. And you can read their personality types on the document. One's a people pleaser, one's a preemptive, one's a procrastinator. They have different drivers, different motivations, that kind of thing. And you're managing this team, basically. And in the second page of the document, there are 3 situations. In one situation, 2 of the people are getting into an argument, and they have a conflict. And basically, you need to choose how you might resolve the conflict, the best way to resolve it, through a meeting, a phone call, etc., so forth, and then go from there. The second situation is one person in particular, I believe it's Fido, you've delegated some power to Fido, some authority, responsibility, and so forth. And Fido has started abusing that authority, okay, basically. And so you need to figure out how to take back that authority, perhaps, how to resolve that conflict, and how to treat him here on after. And there's a third scenario, again, involving conflict between 2 people. But anyways, the point of this exercise is to try to replicate the real world in a classroom setting, basically, to where you're not dealing with these people in silos and vacuums, so to speak. Instead, you're dealing with conflicts between them, conflicts in the team, how to resolve them, and so forth. The other takeaway from this exercise is that you may see these kinds of questions on the final exam at the end of the semester. So, anyways, that's about it for that exercise. We spent about 20 minutes in class on it. In the broader picture for our class, we have gone through, there are 5 major big project management processes: initiating, planning, executing, monitor and control, and close. So if you remember from day 1, we had initiate, fairly short process, kick off the project. Once we do that, we start planning, right? So for example, you planned your first semester at CSU, what classes you would take, what professors you would take, what materials you would need, what kind of schedule you have to make. And then as you start doing the work, you execute. Plan feeds into executing. As you start doing the work of the project, you may go back to planning, of course, at some point, and then iterate between the 2, basically. We spent quite a bit of time on planning, a week or 2 on executing. The 5th process, when we get to the end, is closing the project, usually fairly small, fairly short process. And the one we'll concentrate on next is monitor and control. We typically monitor project work, project team members, and control their behavior and control stakeholders in certain ways while we're executing the project, while we're doing the actual work of the project. So these 2 sort of go in sync, basically. But this is our 4th process, and that's what we're starting with in this module, so to speak. Erase this. The main topic for the day, and the only one we actually do in any kind of detail, is called Earned Value Management. It is one monitoring and control, or actually monitor tool that you can use in a project. Again, it helps track the triple constraint of a project. Remember, our triple constraint is time, scope, and cost. So if one increases, typically the other 2 will increase, or at least they're related to each other in some way. So you reduce the scope of the project, and you reduce the schedule, reduce the cost likewise. Again, not always, but often in projects. This monitoring tool, it's a monitor tool, allows us to track specifically time and cost in a project. Okay, so we can tell by using this tool, are we ahead of schedule, behind schedule, or right on schedule? And the second question is, are we ahead or over budget, under budget, or right on budget, basically? But it takes into account various measures to give us the answers to those two questions. Are we on schedule? Are we on budget, basically? Let's see what else. Two more aspects about this before we get into the details. One is you must have a good baseline. This tool is only as effective as it's only as effective as the strength of your baseline. So the better your schedule estimate at the beginning of the project, the more effective this tool will be. The better your initial budget estimate, the more effective this will be. And of course, the stronger your scope statement and the more concise and specific it is, the more effective this tool is. So again, a good baseline. The second aspect of this tool, you can do it at any level of the work breakdown structure. And for today's illustration, we'll just do one activity as an example of earned value management. But recall our work breakdown structure could be demolish the room as one phase of the project if we're doing room renovation. And we have various activities in it, 4 or 5 activities. And then we have prepare room with a couple of activities. And then maybe it's 2 or 3 more phases of the project. We could do earned value management for just one activity, or we could do it for the entire phase of that part of the work breakdown structure, basically. And again, we'll get into an example of just one activity, but then you could expand that to the entire phase or the entire project for that matter. There are a couple of formulas. They're fairly simple, fairly straightforward. So we'll apply EVM, or earned value management. And our example to do this is, let's pretend we're going to paint a bedroom, okay? So we have a single activity, and not bedroom, but a classroom, to make it more simple. Paint a classroom. And again, we're trying to answer 2 questions. Are we on budget, or are we on schedule? Our first estimate, our first number, is planned value, or PV. This is our approved total cost estimate. And just as the name suggests, it comes from the planning stage of our project. So when we plan to paint this classroom, or whatever our renovation project is, we came up with an estimate of how much it would cost to do that. And to put a dollar figure on it, we're going to say this cost, we plan to spend $400 to paint this classroom, okay? That's the total cost. That's materials, labor, everything, okay? $400. Our second number is actual cost, or AC. This happens during the execution phase. So our planned phase and then our executing process, we actually did the work of the project, and this is the total direct and indirect costs. Direct and indirect costs. Again, incurred during execution, during project execution. And let's pretend that we spent $300 in labor and materials when we actually painted the room. That was our actual cost. So again, just to reiterate, this happened during the plan phase, planning process, and this happens during execution. We have 2 estimates so far. We planned to spend $400, we actually spent only $300. Looks good so far, right? Our next numbers earned value, or EV. Earned value is not really a monetary figure, so to speak. It's just a value you place on the physical work that you gain during that activity. Let me see. So it's an estimate of the value gained for that activity or that work phase, basically. How do we get that number? It's actually another formula. EV equals the planned value multiplied by the rate of performance. Remember, our planned value was 400 in our illustration. Now the question is, how do we get the rate of performance? Let's pretend that we planned for it to take 1 day to paint this room, okay? We hired, for example, Mark, maybe a student, to paint the room, and we said it should take you 1 day to do it, okay? So in one day, he should have 100% of the work done. So 1 day, 100% of the work done. Let's say it took him 2 days to do it. So the rate of performance, or RP, is actually going to be quite different. Let me erase this and explain it in greater detail. So rate of performance equals the percent of work actually completed divided by the percent of work that you plan to have completed by this point in time. So again, back to our illustration of the room. Let's say here's 1 day, 100% of the work should be completed in 1 day. Let's say after 1 day, he's only halfway done. So after 1 day, he has completed 50% of the room. That's a problem because after 1 day, we plan for him to complete 100% of the work. So again, at the end of the day, end of the eight-hour workday, he's only painted half the room. He's only actually done that much work. But we planned for him to complete 100%, right? Of course, if he had finished it all in 1 day, this would be 100%, right? All done in 1 day, 100%. What if he had done it in half a day? And of course, it would be he's completed 100% of the work in half the time, which is very good, right? That's a good number. But again, that's not the case in this illustration. So here's another day, and he stretched it. So his rate of performance is actually 50%. He's working half as fast as we planned for him to, basically. So return to our illustration. Our rate of performance is 50%. And we could do a few calculations. Our planned value was 400 from our illustration. Our actual cost is 300. Our earned value was planned value multiplied by rate of performance. Planned value, actual cost, earned value, planned value again, and then rate of performance. Our planned value up here is 400. Multiplied by 50%. Again, he's working half as fast as he should. This is going to equal 200. So now we have three estimates. We have planned value, 400, actual cost, 300, and earned value is actually 200. Okay? Now, back to our two questions. Are we on schedule? Are we on budget? Cost variance, to answer the cost question, earned value minus actual cost. So we take 200 minus 300. Negative 100 is our cost variance so far. We'll come back to that in a second. Our second calculation is our cost performance index. We take the same two numbers, but we don't subtract this time. We divide. EV over AC. $200 divided by 300, which is 0.67, right? Negative numbers here are bad, okay? Positive numbers are good for cost variance. But more importantly, let's focus on the cost performance index. Anything less than 1 is bad. So less than 1 is bad, basically. A value of 1 means you are right on budget. You are spending just as much as you had planned to. And anything greater than 1 means you are under budget. Let me write these over here. So for cost performance index, anything less than 1 is bad. 1 means you're right on budget. You are spending just as much as you had planned to. And anything greater than 1, it means you are under budget, which means you're saving money so far. That's good. So over budget, on budget, and under budget, spending less than you planned to for cost performance index. Let's talk about the schedule. Schedule variance and schedule performance index. Two very similar, very analogous to the cost measures we did. For schedule, we have EV minus PV, earned value minus the planned value. Back to our numbers, which I just erased. Planned value was 400, actual cost 300, and earned value was 200. So here's this 200 minus 400, negative 200. Just like the cost measures, negative numbers are bad. That means we are behind schedule. Similarly, we take earned value, divide it by planned value. $0.5. Same as the cost measures. Less than 1 is bad, 1 is perfect, and over 1 is good, basically. So this tells us that we are behind schedule, basically, when we have a less than 1 number for schedule performance index. And similarly for schedule variance, a negative number is bad. This project is over budget and behind schedule according to these measures so far. So again, similar to cost, schedule performance index, less than 1, bad. That means we're behind schedule. 1, on schedule, and greater than 1 is, quote, good. We are ahead of schedule, basically. So far, so good? Lastly, we want to know, based on this, what we know right now at this point in the project, how will we finish at the end of the project if we keep going at this rate? There's 2 measures we can do here. One is estimate, particularly cost estimate, at completion. Very simple formula. We have our planned budget at completion. In other words, how much we plan to spend for the whole project, the entire project. We divide that by our cost performance index. Let's pretend that we plan to spend $5,000 for this whole room renovation project. If you recall from an exercise, our CPI was 0.67 that we calculated just a few minutes ago. This gives us a value of $7,462. So if we kept going at this current rate, we would end up spending $7,462 on this project, but we only plan to spend $5,000. So clearly, we are over budget, right? We're going to spend more than we plan to, which is a bad thing, negative. So it makes sense that this is less than 1 here. We're going to get a bad number or amount greater than what we had planned for to spend. But again, this is the total budget for the whole project divided by our CPI will give us this number. So if we keep going at this rate, we'll end up spending this much money. For the time estimate, we have time estimate to complete. Again, an original time estimate. I will say plan to be consistent. We divide that by schedule performance index, SPI. Let's say we plan for 10 days total for the whole project. So to renovate the entire room, it's going to take us 10 days. That's what we planned on doing, 10 days. And again, you could use hours, weeks, whatever time estimate you want there, just to be consistent, of course. So we'll say 10 days. Our schedule performance index was 0.5. Do the math, and you get 20. So at this rate, it's going to take us twice as long as we originally planned for the entire project. So instead of taking just 10 days to do it, at this rate, it's going to take us 20 days to complete the project. So again, these are bad numbers for this project, but they correlate, as we expect, with our index numbers here. So it gives us an estimate of how long it will actually take us to complete the entire project at this current rate. And again, this is just one tool that sort of integrates, as we reiterated earlier, the time, scope, cost equation of a project, the triple constraint. Because it could be a little bit deceiving if you go back to our original values. So again, so far our planned value of 400, actual cost 300. So at this point you're telling yourself, we plan to spend $400 on this activity to paint the room. We only spent $300, so things look good, right? What you're missing from this equation is the time factor, basically. And when you throw the time factor, or specifically that rate of performance of 50%, it's taking them twice as long as it should, that can really reduce the budget estimates and the time estimates as well as a negative factor in your project. So again, this is mostly just a cost for the actual cost part, and this is the time factor that are critically important for this tool in particular. And so in the next class, we'll probably do a few exercises with earned value management, some different ways of looking at it. And again, it's just one tool to help you monitor project work and project execution, basically. And that's all for today. So I'll see you next time.